Okay, so our research panel is about multimodal conversational AI and future dialogue challenges. As I said, I'm your host today, Dr. Kulvinder Panasa, and I have my international colleagues with me today. So I will be introducing them shortly. I am a lecturer of applied artificial intelligence at the University of Bradford. I am a computational linguist and a computer scientist. I'm interested in linguistic NLP and statistical NLP in the conversational dialogue space and looking at the hybridization in that space. So I'm currently working on a project looking at pre-screening a conversational agent for people concerned about their memory. So I will pass you on to my colleague, Professor Maria, who will introduce herself, please. Thank you.
Yeah, thank you, Kulvinder. Hello, everyone, and thank you for attending this panel. My name is Maria Beatriz, and I am a linguist and also a knowledge engineer. I am an associate professor in linguistics at the Universidad Nacional de Educación a Distancia in Madrid, and I teach both theoretical and applied linguistics. I am currently the Vice Dean for Research at the Faculty of Philology. So for the last 5 years, I have been part and parcel of a virtual laboratory called Functional Grammar Knowledge Base. And I have done research in 2 different fields. On the one hand, I have been working on the design and population of a knowledge base, more specifically on the population of concepts of the general ontology and on the lexicon module of English and Spanish. On the other hand, I have used the general ontology of this laboratory to dive into the studies of semantic memory loss in patients with Alzheimer's and a setting from transcribed oral corpus of people with Alzheimer, and with the aid of Fangram KB's ontology, we were able to trace the conceptual change of the responses in a corpus of oral definitions of semantic categories. And this study was important for the detection and classification of Alzheimer cues. So currently I'm working with Dr. Kulvinder on a hybrid model, which is linguistic and artificial intelligence, to be implemented in a conversational agent for the detection of cognitive impairments. Thank you very much.
Thank you, Maria. And Dominic, please.
All right, thank you for being here, for having me. My name is Dominic Simon. I'm an associate professor with the Department of Software Engineering at LUT University in Finland. I conduct research usually in the field of information systems, so socio-technical systems. I look at the interplay of humans with technology, so on behavioral aspects as well, how humans behave with technology, but also on how to design technology. And in doing that, I focus on interaction and collaboration with intelligent systems such as conversational AI and conversational agents. I would like to talk about 3 projects that I'm currently working on. One is the idea of having something which we call a virtual collaborator, which goes beyond the sole conversation. So whenever any form of intelligent systems also contributes in any kind, adds some content, makes decisions, or also delegates any tasks, then I try to find out how team behaviors, group dynamics change when this system is employed in a team, for example. Then, on the other hand, I work with very talented researchers, for example, on the idea of something which we call personality adaptive conversational agent. It's a way of conversational agent that is able to capture the personality of its users in order to adapt to its users. Conversational agents right now at some point are a one size fits all. So every user gets the same conversational agent, which we all know is not always good, not always feasible. And this personality adaptive conversational agent is able to capture the personality of a user and then adapt accordingly. Another project that I'm working on is something we call virtual companion, in which we try to incorporate theories of interpersonal relationship, especially of companionship, into conversational agents. Something like a reciprocal interaction, that we build relationships with existing conversational agents. We found out that these can be, for example, highly beneficial in a context like in-vehicle co-driver. So coming from an assistant within the car who just assists a driver more towards a co-driver who reciprocally interacts with the user. Also in a learning context that could be very beneficial. All right. Thank you.
Thank you so much. And Angus, please.
Hi everyone. Yeah, also happy to be back. And well, I was here last year for those of you that were here last year. And yeah, I'm Angus Addlesey. I'm a PhD researcher at Heriot-Watt University, and or I was until yesterday. I've not finished my PhD, but I'm going to start an internship at Amazon as an applied scientist in a week for 5 months, and then I've got a new research position at Heriot-Watt University again with the Interaction Lab. So lots of exciting things for 2022. And my main interests are sort of voice accessibility. So adapting voice assistants for the users that sort of can make the most benefit from them. So yeah, people who are maybe visually impaired or people with memory problems where reminders and sort of, using interfaces is not as simple as using your voice. So yeah, how do we adapt these voice assistants to the user? And that's sort of my main area that I'll talk about today.
Thank you, Angus. And Stefan, please.
Yeah, hello everybody. Also, warm welcome from my side. I'm also very happy to be part of this panel today. My name is Stefan Ultes. I am Dialogue Research Bands, where we built one of the leading in-car voice assistants that you can find in the car. And there, the research we do focuses around natural interaction and everything that's connected to that, roughly speaking. So within the past 10 years, I've been involved in many different aspects of spoken dialogue systems, technology research, mostly focusing on introducing machine learning technology into the overall dialogue systems. I've looked at different aspects like emotions and user satisfaction, how to make use of that in dialogues, how to use machine learning for argumentation in dialogues, how to build up arguments, how to have a model for arguments that can be used by machine learning methods. I've looked at communication style, what different communication styles are there, what are there differences between cultures, and so on, and how can you realize those from a technology point of view within a dialogue system. And I've also looked into novel graph-based models of representing the internal state of a dialogue. So what are the semantics that have been conveyed by the system and the user in the context of task-oriented dialogue systems. So where a user wants to get some tasks done by a system.
Okay, Stefan, Angus, Maria, and Dominic, that was amazing introductions, and there's given us a lot of food for thought. So let's just a bit of housekeeping first of all. If you have any questions, please add them to the Q&A tab, and any obviously comments into the comment section. So let's get started with this now. So we're going to start off with this question, and we're quite excited to sort of like explore this. So our question is, what would users expect that virtual companions or conversational AI products will look like in 2030. What will be the blockers and challenges of this? So just as a backdrop to this, what I wanted to is just highlight a couple of things. So there's been a some of the historically conversational AI has sort of evolved out of that retail space where everybody's wanted a lot of personal customization, customized conversational AI assistants. There's going to be a rise of potentially up to 70% of chatbot conversations in the retail space, looking at customer behavior, predicting customer behavior as well. So it seems to be that trend seems going to follow through. Now, the other thing that and I could go through loads of different domains when we want to explore our opening question. But one of the biggest things to hit us is going to be, the metaverse. Yeah. And trying to introduce that here, I think is really important. So just in the earlier talk, Jeff Blackenberg, he alluded to the future of people, and he talked about trust in these new spaces, not necessarily referring to the metaverse, but the future of people. Now, when it comes to the metaverse, what is it? It's the next universe. What will it look like? And just to give you where's this come from? So Mark Zuckerberg, he basically said it's the embodied internet that you're inside of rather than looking at. And he believes it's going to be the successor of our mobile internet. Now, the metaverse, the next universe, where will people be? What's the spectrum? Will there be, what's the spectrum from, being physical, some sort of, to embodiment? Where will people be? And, what about the multimodal nature of it? Your voices, your gestures, your facial expressions. What will this look like? So let's tackle this. So Maria, Stefan, Angus, Dominic, I will, give you a chance. Whoever wants to kickstart that, Stefan, Dominic, Angus, or Maria, from any angle you want to take this, and we can work through it. Okay, so we can take any angle. So Maria, you talked at length about your work, and you talked about, the linguistic sort of dimension when it came to this. Do you want to sort of expand on what you think it's going to look like?
Okay, yes, thank you. So, of research, that of cognitive and language impairment, I don't think metaverse is going to be straightforward, since it implies a more difficult cognitive situation for people who have already problems of communication. But I can see an expansion of virtual companions for healthcare, especially conversational agents with or without embodiment, right? So I think we have to make an effort and try to implement systems which are based on deep semantics. That's the way, in my view, agents are going to be more human-like. So I know this is costly, but I think it's the way to enrich natural language understanding with deep semantics is a non-controlled setting, because with a controlled setting, right, like, selling a train ticket or a flight, a plane ticket, that's a control area, and you can get very good, results only with artificial intelligence. But when it comes to, real conversations of, daily life, I think a understanding is, a deeper understanding is necessary. So we will according to my linguistic point of view, we will to represent knowledge, be it through as being already suggested, or ontologies, right? And we will need a model with a cognitive architecture with three main levels of knowledge, right? A lexicon, of course, we need the words we are going to employ, and these are the words. The lexicon is specific to a language, so we will need lots of lexicon, for all different languages we want to work with. And then we will need, of course, when we are in the bit we are working with natural language, we will need a grammar, and then we will need a cognitive level, and according to the model I have been working with, but I know it's just a model, but I've been reading, and there's some other models which also care for this cognitive level, right? So I would suggest that we will need a onomasticon, which is a named entities repository, right? And then we will also need a cognicon, which stores procedural information by means of scripts, right? And these are conceptual schemas which describe events in a temporal frame. For example, how to make a Spanish omelette, or how do you make an online bank transaction. And finally, we will need a general purpose ontology with all the concepts arranged in a hierarchical way. And this cognitive level, it will be universal, will be shared by different languages. And the only thing it will be different is the cultural approach. But that would be easily implemented in these scripts or even named entities, right? So that's my view from a linguistic point of view.
Thank you, Maria. So you have your knowledge, your cognitive, and your lexicon. Those are the key areas that you've addressed that need to be within our modeling space. So Stefan, do you want to go all the way to the other side, and let's look at you've been using a host of natural language processing models. Do you want to tell us how that is going to fare in the space, and what will it look like in 2030?
Well, from a interaction point of view, I would say that for something like the metaverse or anything like that, interaction modeling would be quite similar to outside of that space, and the core questions will remain the same. How can we build systems that are able to understand what the user says and come up with a reasonable reaction to that? And there are a lot of natural language processing approaches, machine learning approaches that have been introduced recently. If I say recently, it's probably not that recently. It's also already some years ago. Most notably, the transformer model has been quite popular, which is a statistical language model. It kind of looks at words and computes statistics of what is the probability of a sequence of words or a sentence, or however you might call it. And transformers have been introduced with a new mechanism, and they are able to look at the whole sentence as a whole and not just process every word piece by piece. So we can basically look at dependencies between the words and combine meaning and everything. And this has been a huge breakthrough, but there are still and it's used widely if you look around. I mean, if you want to publish an NLP paper, the machine learning oriented conference, and you don't have the buzzword key transformer in your paper, it's usually a bit harder to get it published. But still, it's not like the solution to everything, because I guess well, there are several problems with transformers, or where they are limited. But I guess the most important insight is that they basically don't encode meaning. They just look at words. They just look at the word level. They compute probabilities over word sequences. So they only look at the tokens themselves. If you say, okay, this is a tree, or you replace the word tree with whatever else in the text, it will give you the same probability, because it's not grounded in the real world. There's no grounding outside of the linguistic level, and this is basically missing. And this type of understanding is what you actually need in order to go to the next level, to go beyond where we are, to have actually a system that's actually capable of being able to converse with people in a natural way, in a user-centered way. I'm very sure this is where we need to go for. This is what interaction would look like in 2030. People would expect a system that's similar to what a human can do. The system is able to adjust its behavior to people, to a personalized user experience, if you will, as Dominic already said earlier. So this is definitely something that users will expect, and also expect more natural behavior, not only in terms of the semantics of what is said, but also the actual words chosen to actually convey the right things to people.
Okay, thank you, Stefan. So, that core question, like you were saying, the core questions are still going to be the same, and currently that challenge of encoding meaning is going to be long-standing and will still be long-standing. And obviously, there's attempts with the state-of-the-art models to work towards that direction as well. Okay, so we've got two ways we can go, looking at the behavioral side, or we can look at the meaning side. So, Angus, let's look at from a design, and also when it comes to meaning, because you were talking about this earlier.
Yeah. So very, to tie these two different points together, I'm trying to tackle a specific problem, and I've taken two different approaches, or will do. Neither are complete. But when we talk to these voice assistants, for the most part, especially sort of ones that you can buy online, not research systems, they take your full sentence. They take what you say the wake word, Alexa or Google. You say your sentence and you pause, and this sort of detects the end of turn, and it processes that and it uses all that information. You wait your turn, and then it responds, and you take these turns. But that's not how we have human conversations. So we learn this behavior, but if I say yesterday I had crackers, and you have some form of understanding of what I'm saying. You don't need me to say grapes for you to then go, okay, well, it was yesterday, he was eating something, one of the things was crackers. You understand partially of what I'm saying before I finish this sentence. So how do we make these systems more natural? And this ties to my work with people with dementia, because they pause in the middle of their sentence more often. Do they need to learn how these systems work in order to interact, or should we try and make these systems more naturally interactive in that they don't need to learn? We can just talk as if it was a person. One approach we took was this linguistic approach with a lexicon. We've got a demo working. It generates graphs sort of as you're talking, representing what is being said. The understanding of what is being said as it is being said, word by word. And with Amazon, what we're going to do is take a neural approach with transformers, of course, and then we're going to evaluate both of these on a data set I'm currently collecting. And what do we expect? What are the differences here? Well, one of them is going to make stuff up. The transformers are likely to hallucinate, it's called, where they'll maybe understand something that didn't actually exist. And that's very common. If you talk to maybe GPT-3, you can type in things. You can sort of completions of sentences. It will maybe make things up, and there are lots of tasks built on BERT and GPT-3 and other transformer models, where you give it data and it will create a summary of that data, but it will make some points up because that's what it's seen in its sort of training text. So the linguistic driven approach will likely not do this, but it's not going to cover as wide number of words. You have to have this lexicon that covers all of these different words that people can say, and language changes over time. It's not going to understand this is lit fam or something, I don't know. So it depends on your use case. So with people with cognitive impairments, you really don't want to have these hallucinations. You don't want to tell someone something that's not true. So in some use cases that's more important, in some use cases the other, and of course you can sort of try and combine these methods. So that's my 2 cents on, I don't think that ties to the metaverse, but I agree that sort of speaking to a voice assistant in any embodiment is similar.
Okay, thank you, Angus. And I like the idea that transformers are hallucinating. It just really puts it into actually gives you a sort of a reality check as well, doesn't it? Now that was very interesting in that you're looking at the comparison, and Maria earlier on was talking about the hybridness that will hybrid approach, and Stefan referring to obviously the core questions and also the interaction, and obviously that meaning representation that we're looking for. Now, obviously that's from a computational, how can I put it, computational processing of language. What about the behavioral side? How will it look like, Dominic? I mean, you talked to us earlier on it, but if you want to just give us a sense of what will the behavioral side look like, or from the design side as well.
All right. I think it's a good way to summarize what everybody said, because I'm not that deep into the technical aspect, but yes, I think this is the important foundation for having conversational AI in 2030. We need these techniques in order to make conversational AI somehow better. Because why are we actually interacting with conversational AI? Because conversation is a natural way to interact. That's why we want those conversational agents to be more natural, and that probably means to be more human-like, to adapt to each other, because we are all individuals. So everybody speaks different. We have people with dementia, we have people with other impairments. So we need conversational AI at some point in 2030, maybe, to be really user-friendly and human-driven. So to adapt to a user at some point, to his or her language usage, to the personality of the user and the individual needs. So this is a very important aspect, in my opinion. And I think in 2030, we will have, not sure if it's really related to the metaverse, but we still have text-based conversational AI, but also voice-based conversational AI, embodied conversational AI, and non-embodied and conversational AI, because all of these forms of interactions, they have their benefits. Usually you use voice-based, but at some point, writing a text is can be more beneficial, or you can capture a message better, for example, in a love letter, which you write instead of talking about it. So we will have all these different forms of interaction, embodiment or not embodiment. So it just needs to be more natural, more human-like, as actually everyone already said. But there are other forms, maybe a more controversial idea of how conversational AI could look like in 2030. We all were thinking about having conversations without even saying something or writing something, because we all were thinking about if it would be nice to read each other's minds, that would be something. And here we can combine these with some form of brain-computer interfaces, which we can use as well. So I think there will be more and more possibilities. The end goal, the goal that it will lead to, will probably be as natural as possible, and maybe even augment the skills that we have, because we can write, we can use sign language, as I saw in the Q&A, which is natural as well. So CAs should be capable of using sign language, but maybe also able to read each other's minds using brain-computer interfaces. So yeah, I hope that will be 2030. Maybe it will be earlier, maybe it will be later. Depends on how much research we will do.
Okay. The brain, yes, so obviously by 2030, obviously the brain computer interface space is also really there's a lot of exploration going on, and you know there's been some positive results with that as well. So a combination, the possibilities, you're so right there. So what we'll do is we'll come to that, back to that question that Pilar has put in. What about the sign language and the virtual assistant bots? Do you see any future for this particular field to be developed? Now, I'm just going to kickstart this. So Maria and I both work on a very mature functional linguistic theory called role and reference grammar. Now, what role and reference grammar can do is it can actually describe, explain, and it obviously observes what the sentence is, and we can create a meaning, basically a logical representation of the utterance. Now, as part of our community, we actually have a massive project, especially for the Irish sign language, where they're looking at obviously using the linguistic theory and using gestures, and creating an interface between the linguistic theory and the gestures in order to represent those gestures as text in textual form. And obviously taking one step further is obviously supported if there's any and there's voice alternatives of that as well. Now, Maria, do you want to just expand on that a little bit? So one of our colleagues obviously has been working at the Irene Muchka as part of the role and reference community. She's working on a big project. Do you have any details to add to that?
Well, not really, Gulvinda. People working in my group haven't worked in sign language, but I've been to several conferences with colleagues from Ireland.
Yep.
And they've been telling us their progress. Yes, and I think it's very interesting and very necessary, especially if we want to transcribe gestures to language, written language, and then to spoken language. And I think it's going to be very necessary. Yeah,
certainly. So the space, so they work on this with the Irish Sign Language, and I believe they are looking at other alternative sign languages as well. So if anybody wants to know anything more about that project, I do have information about this project, so I'm happy to assist there. Anybody else want to support Pilar's answer for this question? Yeah. Anything to add?
No, just that visual communication is very important, and something that we're hoping to work on in the future. And we nod and we sort of make gestures all the time, like pointing to things and saying we like that. And sign language is a very good use case of visual communication that often goes overlooked.
Brilliant. Anything to add, Stefan, Dominic?
Just agree on that. We just recently launched a paper on how body language reflects personality. So embodiment and really using that is important as well. So you can use it when you design any form of conversational agent, but also using cameras and computer vision in order to capture sign language or body language. Very natural way to interact. So I think it's very important.
Okay, so there's two takes on it. So we've got a linguistic theory which can actually represent those gestures, and then you've got the computer vision version. Obviously detecting those gestures and then obviously interpreting those. Yeah, so there's two different bodies of thought there. Okay, we haven't currently got any more questions there, so I'm just going to pick on a couple that I can throw at you actually. So Stefan, okay, so Maria was mentioning the hybridness, and Angus is looking at the comparison, and will be able to maybe even support obviously a hybrid project if we were to think about it. Now, Stefan, if what I was just trying to, with your thinking caps on now, if we had this hybrid approach, because it seems like, there's Gary Marcus just recently introduced this hybridization concept, which has actually also been, it's been around, but people are actually thinking about it a lot more. Now, what will that hybrid approach, do you think, look like? Any particular, what would be the most major factor that you would think would support a hybrid solution? What is,
I guess the difficulty here is that if you look at it from a machine learning perspective, machine learning works very well in its kind of within the machine learning world. If you have like all those numeric representations, vector representations of whatever, you can apply functions over them. You can compute gradients over the functions you've applied to them, and all of that, and you basically never need to make or if at least if you're in the neural world, you don't need to make you don't want to make concrete decisions until the end, until the network is done computing, because if you make a concrete decision, it's very hard to compute a gradient over it, so you cannot kind of do the back propagation, which is kind of the important part where you train those neural models. So so if you want to introduce like symbolic information, which is basically what you want to do if you go towards hybrid towards hybrid systems, where you say, okay, I do have a lot of additional information, I just don't get a bunch of data, I do have linguistic information, I know I do have a lot of structural knowledge about how the linguistics look like. I don't know any parsing world or whatever you want to incorporate there. So you need to have like methods of incorporating that into your neural model. But there are actually a lot of ideas already around in the deep learning world that are able to do exactly those things, to be able to look at to look at those symbolic representations and incorporate them into the deep model. But this is just only one representation, right? I mean, if you look at a concrete problem, you can introduce this type of symbolic information at so many different levels, right? And you don't need to introduce it at the neural level. You can also say, okay, I do have my neural model to do some low-level classification task, and then I apply some symbolic method over it and compute and get something out of it. And that basically there's so much room in where we do the hybridization that it's really that there are so many different things to explore in the future. So I really hope we will see a lot of very interesting ideas coming up soon.
Certainly. So can I just put one little, just to, based upon those different ways, what about the control aspect of a hybrid solution? Will that be a major challenge? Where do you see control? Because obviously if it's in different form, it's at different layers. Yeah. So how will it be controlled?
Well, control is just one other aspect, right?
Yeah.
Of symbolic information. You want to have especially if you want to design a conversational AI system, and I guess that's what we're all here to talk about. So then oftentimes you just don't want to let a machine learning based model do whatever it has learned, but you won't be able to insert some control signals. So as a system developer, you can control what the outcome will be. So provide additional information. I think that's an important aspect of bringing those machine learning models into the production world, I would say.
Okay, so that's great. what we'll do is we'll come on to those questions. We've got a couple more, which is great. So we'll just go from the next one is, I think the person is referring to sign language. It's that comes to mind. It says sign language could be translated by any sign language languages or between oral languages as well. Have this been explored in any applications? Does anybody have anything to add on that? So they're stating that if it can be translated, can it move from one to the other? Can it be translated?
I mean, I know that, again, transformers have made huge ground in machine translation because you can pay attention.
Yes, yeah.
I don't know if sort of those, yeah, I imagine that can probably be used in sign language, but yeah, I've.
That's a very unique, it's a unique case that is possibly is possible from our current understanding of that space. Is that fair to say that it could be possible? Let's go on to Jack's question. So he's saying, following up on transformers, and which he goes on to say, which I gather from the group, is not going to be the solution for multifunctional model dialogue in the future. Besides knowledge graphs, how can natural language systems get deeper in the sense predicting conversational behavior across modalities? Dominic, do you want to have a go at that?
I think that's a bit technical for me.
Okay. Okay.
Similar to the machine translation thing, exactly. I can maybe add one sentence. So when you take these transformer models and you are doing what are called sequence to sequence tasks, where you're taking a string of words in one language and maybe outputting a string of words in another language. I think I wouldn't say that transformers are not the way forward, but I'm biased here. What I'm hoping to do is, instead of doing text to text like this translation example, we take the sequence of words and output the graph representation. So I'm biased towards knowledge graphs, but that is how I see a good multimodal approach working. I've done work in the past with computer vision models outputting knowledge graphs, and if you have both of these sort of a transformer model changing the text into a graph and the computer vision model outputting a knowledge graph, and you could reason across those, that's something that I mean, that's essentially my thesis. So I'm very biased, but yeah, I don't know, that's my 2 cents on that question.
Okay, Stefan, do you have anything to add? I mean, I'm in a similar viewpoint that knowledge graphs seem to be, I'm biased towards knowledge graphs, so that's an area that I am exploring as well in the current research that I'm doing. Stefan, do you have anything to add to that?
Yes, maybe to the first statement that these transformers are not the solution.
Yeah.
I think they can be part of the solution. I mean, we have to be aware of what they can and what they cannot do, right? So what do they actually do and how can they be used the best way based on what they are able to do, but where are the limitations? What is something they are not able to do anymore, right? This is why I mentioned this understanding situation, that they don't really understand what has been said, and then it's really hard for them to come up with their own response, like GPT-3 does, for example. It looks human-like, but it's just because if you look at something and you say, okay, this could come from a human, doesn't really mean a human would do it, right? It's not the same. So the first part, I would mildly disagree of this question. And in terms of NLU, it's really hard. I'm not an NLU expert. My focus is rather on the dialogue side of things. And people can obviously argue where the border is of those two things. But from my point of view, NLU that can benefit from transformers, from their ability to process linguistic data very proficiently. But then again, there needs to be something on top, which I have no idea what this would be.
Okay. Thank you. Yes, so that's why we're researchers and we're exploring this space. So just another question related to Alexa or Google Assistant, Angus. without, so somebody's talking about the multifunctional conversational AI in languages without massive political economic power. Do you think we will see this multifunctional conversational AI in languages without massive political and economical power, as they already suffer to have available options in devices like Alexa or Google Assistant? So you're going to work, you've got an intern at Amazon. What can you tell us in as a response to that question?
I've not started, but I do know that they along with the other big companies, are interested in low resource languages. In particular, if they want to train their system to be more natural at a particular task that doesn't have that much data. So not just low resource languages, but low resource tasks, I guess. Sort of from a few examples of human interaction on a particular thing. How do we learn that and implement that in this sort of systems where they usually have huge data-driven models that have millions and millions of hours of data to work upon? So that's the direction that I would say I can see the bigger companies taking. In the research community, there's a lot of work on low resource languages. It's very interesting and not something I know much about, as I'm trying, but I'm still, I would say, I'm not bilingual in any regards. I can so I have I can't really help in this way, but there are lots of people from these countries grouping together and teaming up with other researchers and trying to implement models or even just collecting that data. And I think one other thing I could maybe mention is Wikipedia sort of has a lot of bias depending on the language it's in. So maybe if there was a war in the past and you look at it from one country's Wikipedia page, it has different factual, statements than in another language. So what they are trying to do with a project called Wikifunctions is represent all of these things in lots of different languages in one central place. So then you can find these sort of contradictions. And also in some languages like English, if you go to a famous figure like Mother Teresa, there is certain pieces of information that if you go to in a low resource language, someone has not edited that page, so it's a sentence. So they're trying to do this to try and, I guess, populate Wikipedia pages in low resource languages and also gather information about, food recipes, culture from, some, I guess, parts of the world where less people get involved.
And Dominic, sorry.
Can I add something to this?
Sure.
So, sorry sorry for interrupting. So I guess one of the problems that we see with state-of-the-art models that they really need this huge amount of data, and I think that's the critical part, right? But to be honest, I'm rather optimistic. If I look at speech recognition, which already also uses a huge number of data, but there they are managing to add more and more languages to their devices. Also, we at Mercedes, we have more than 20 languages that we offer our system with, right? And this will be expanded as well. Also, so if we see this in speech recognition, I'm rather positive that in the future, also with all the research on reducing the data we actually need, doing transfer learning, being able to transfer from one language to another, and so on, that this will be at some point in the future also available for languages that are less economically powerful. Okay.
So just to add on that, so there are companies which are already collating models for translation of text, and obviously T5s and the state-of-the-art ones. So there's one particular company that Maria and I were working with is John Stowe Labs, and their NLP models are definitely are showing a lot of positive results when it comes to that translation of text. And let's Dominic.
Yeah, I just want to add on it and say that it's a very important aspect. We had similar problems in our research when we wanted to capture personality traits of written text and users for our conversational agent. And we usually I use systems, available systems as well. And we found out that most of them only work for English or for Chinese and the most popular languages. So we had to develop a system on our own based on German language. So I think especially those companies that are very commercially driven, they of course want to get the huge user base, and that is English speaking, maybe Chinese, the big language is Spanish. But still research is doing a lot of things. I don't know all the research. I know that we do something for German language, but I think that is one of the parts to make conversational agents available and more natural for everyone, because there are so many languages and there are so many variations of languages in English, in German. We have so many different dialects. So this is important. So I can't emphasize it enough. So good point, Luigi.
Yeah. So what we'll do is we won't take any more questions. So let's just think about, we're researchers. Let's think about, the directions, the mindset that's needed when it comes to taking conversational AI forward. Just a minute more, and then we can wrap up. Is that okay? Dominique, I'll just let you fire there with something pretty. Just brief, please.
Oh, okay, of course. I think you're all doing great research, especially on the technical aspect. So I think we are at the beginning of good conversational AI, which still evolving, needs to be more natural. But one mindset I think that we all need to incorporate is that we need to do a human-driven approach, individual approach. Every human is different, so we need to focus on the user, on the human that interacts with the conversational AI, conversational agent. Be open, also look at minorities, impaired people, which we all do, which I really like. So having a human-driven mindset is very important.
Thank you. And Maria?
Well, I completely agree with Dominic. We need human-centered approaches, and especially for my field of research of this of cognitive impairments, I think a good system, conversational system, and would be of great use both for diagnosis, pre-diagnosis, healthcare companion, and everything we can think of. I think it's very good. It'd be necessary to, as Jeff in the previous conference, we have to look for the needs of people, right? We have to think of the needs, because if we want to, to produce a human-centered technology, we have to know what is really needed, right? And just to take care of different sort of group of people who would have a much better life with these artificial intelligence solutions. Thank you.
Thank you. Briefly, Angus and Stefan, because we've just got our last minute, I believe.
Yeah, no, I think we need more data for certain user groups, and incrementality or understanding as we talk is useful for people with cognitive impairments and people who are distracted driving, and I think it covers everything.
Yeah.
Okay. So I think I'm just going to sort of wrap up, Stefan. Is that okay? So we've all agreed on the hybridization and obviously using it at different levels. And the main thing is that it needs to be user-centered, human-centered, individual, customized, personalized. It needs to have that degree of controllability as well, and some degree of explainability, and obviously headway for more cost-effective computing and meaning representation solutions. So I think that's probably what we've sort of drawn from our, our 50 minutes of the chat. And I hope those questions have been is interested, please contact us for any information or to connect as well. And I think that will draw us to a close. So thank you very much for listening.